Hello, Year 8. Very sorry, but I'm not available this lesson to host a live lesson on Teams. So what I've done is I've made this little recording to explain for you what it is I would like you to do this lesson. Now, last lesson, what you should have done was you should have carried out an investigation into springs, trying to find out if springs follow rules. And what you should have done was you should have used this website. And in this website, you had the spring here that's fixed at one end. And what you then did was you applied force to that spring and measured how far that spring stretched. And using those results, what I'm hoping that you will be able to do is see if you can work out what the rule is. Is there a rule that the spring is following when you apply force to it? Now, I've got here a sample set of results. I carried out this investigation as well. These are the results that I produced. I'm hoping that yours actually should look identical to this. So here we've got the force in the first column. So we've got 0 all the way through to 15 newtons of force. Here we've got the stretch in meters. And I also added, if you remember, that third column where you're going to convert the stretch into centimeters as well. That's going to make our life easier this lesson. Now, what I want you to do in this lesson is you're going to take these results and you're going to see if you can work out what is going on. To help you do that, you are going to need to produce a graph, because that's why we do graphs. We do graphs to help us look for patterns and to make sense of the results that we produce whenever we carry out an experiment or an investigation. So you are going to need, for this lesson, you're going to need a piece of graph paper. Okay, you're going to need a ruler. You are going to need a pencil. Now, I have attached for you to my post on Edmodo. I attached some graph paper that you can download and print off. If you don't have access to a printer at home, but you have got access to perhaps Microsoft Excel, and you think that you can produce your graph on Excel, by all means, please use Excel for this as well. Okay, so to put our results into a graph. Now, we are going to use a line graph for this because the data that we have produced is continuous. Remember, when we think about whether to put stuff into a bar chart or a line graph, if your independent variable, the thing that you changed, is continuous, it should always go into a line graph. If your independent variable is discrete or discontinuous, then it should be a bar chart. But this time, our independent variable was continuous. We could have chosen any value of force to apply to our spring whatsoever. Okay, so we are going to do a line graph. Now, what I'm doing is I'm taking my bit of graph paper and I've placed it in landscape for this. And the first thing I'm going to do is I'm just going to draw on my two axes. Okay, so I'm going to draw on my x-axis. Remember, of course, using a sharp pencil and using a sharp ruler. Okay, here goes my x-axis. I'm then going to place my y-axis at the side here. Okay, like this. And then before I do anything else, I'm going to label up my axes so I know which bit of data I'm putting on which. Remember, we always put our independent variable, the thing that we changed, always goes on your x-axis. That, in this case, was the force that we applied to the spring. So I'm going to label this force. And that is in newtons. We always put our dependent variable, the outcome of our investigation, that always goes on our y-axis. In this case, the outcome, the dependent variable, was stretch. And to make our lives easy, we're going to use the centimetres. Okay, that's why I wanted you to convert it from meters into centimetres. It's just going to make our life a little bit easier when we do our graph. Okay, so let's go back to our results that we produced. Let's start labelling up our x-axis. We went up to 15 newtons. So, okay, let's start labeling that up. Remember, because this is a line graph, our origin, okay, always goes here. Now, what I need to do, I need to try and fit 15 along here. So I've got 1, 2, 3, 4, 5. That's not going to work. So what I'm going to do is I'm going to make every 5 tiny squares or half large square, I'm going to make worth 1 Newton. Now, whenever we do graphs in school, one of the mistakes that you quite often make is that you mix up the scales that you use on your axes, particularly the x-axis. You mix up line graphs and bar charts. Remember, because we're doing a line graph, the number needs to go on the mark. Okay, it needs to go on the mark here. So I'm going to go 1, 2, 3, 4, 5, and so on. Now I'm actually going to go beyond 15. Okay, that's quite a good habit to get into, because if you go beyond the range that you tested, that means that you can actually use your graph to predict results of experiments that you haven't actually carried out yourself. There we go. I've gone all the way up to 26. I know I only tested up to 15, I think it was, but we've gone right up to 26. Right, now let's deal with our y-axis. And if we go back to our results, you'll notice that the greatest number that I've got is 7.5. So let's work out a scale that's going to fit on my my y-axis. So if I go up 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's going to work. So the scale I'm going to use on my y-axis, obviously I'm going to make 0 here, down here at the origin. And what I'm going to do is I'm going to make every 5 tiny squares or half large square, I'm going to make worth 0.5. So let's add my little marks first of all, going all the way up my y-axis, like this, all the way up to the top, and then I'm going to go up in 0.5. So 0.5, 1, 1.5, and so on, all the way up my y-axis. And again, just like before, I'm going to go beyond the numbers that I actually collected. Ooh, I've lost count. I'm going to go beyond the numbers that I actually collected. And again, it's because I can then use my graph to predict results that perhaps of experiments that perhaps I haven't actually done myself. Right, let's go back to my data. So we know the first result we've got when the force was 0, obviously the stretch was 0. So I can add a little cross here at the origin. Okay, let's go back to my results again. When the force was 1 Newton, the stretch was 0.5. So I'm going to go back to my graph. We go along to 1 Newton, we go up to 0.5, and I make a little mark on my graph. Okay, let's get my next result. Sorry, I got hiccups. My next result, when the force was 2 newtons, the stretch was 1.0. Okay, so I go along to 2, I go up to 1.0. Now what I'm going to do then is I'm just going to add all the rest of my results. I'm not going to keep flitting backwards and forwards between my results table and my graph. I'm just going to add all my remaining results. Okay, now a couple of things when you're doing your graph, when you're doing your graph at home, okay, It's really important that your pencil is nice and sharp. It's really important that you make it as accurate as you can. So when you mark the points with the little crosses, don't go, ah, ah. Remember, just nice, neat, tiny little crosses. Okay, right, so there's all my points plotted. Okay, now whenever we do graphs, I'll quite often say to you, right, you need to do a line of best fit. Now what that means is that you show the pattern. Now the pattern for this quite obviously looks like a straight line just going up our page in a diagonal line, and in fact these results are pretty much perfect. Okay, if we were doing this with a spring in the lab, we would expect a little bit of variation, perhaps due to human error and various other things. So what I'm going to do is I'm going to take my ruler. Okay, I'm going to place my ruler on my graph, and I'm just going to draw a straight line through my points all the way up. Now you'll notice that I have gone beyond, okay, I've gone beyond, if I just line it up so you can see it, I've gone beyond where I went up to. So I've gone beyond 15 newtons. Okay, last thing I need to do is I just need to give my graph a title. So I'm going to label mine a graph to show the stretching of a spring. Okay, there we go, there's my title. So there's my graph finished. Now that I have got my graph finished, what I would like you to do is I'd like you to take that graph, take your results. Let's just make me big again. Take your graph, take your results, and what I would like you to do is to write a conclusion. Can you work out what the rule is that springs are, or this spring is following? Okay, I'm going to give you a clue. Start simple. Start really, really simple. Okay. Do you remember? I think probably last year we would have talked about Newton's laws, 3 laws that Newton came up with. If you can refer to them, that would be amazing. Anyway, what we will do then next lesson is we'll have a little look at your graphs. We'll talk about the conclusions that you've come up with, and we'll see if we can work out what rule the spring is following. Anyway, hope that all made sense, and I'll see you soon. Bye.